Hi, welcome to the second video in this series of presentations about blueprints. In this video, I'm going to explain a couple of things. I will show you how a blueprint is structured, how to deploy a blueprint on a public cloud, in this case AWS, and I will explain all the manual tasks that our helper tool, CleanICTL, automates for you. As you can see, in this GitHub organization called Red Hat Edge Computing, we have created two different blueprints. First, the Management Hub blueprint, which describes a 3 masters, 3 workers node cluster running on GCP with a number of tools needed to manage our edge computing sites, basically ACM, our Advanced Cluster Manager. The second blueprint, called Industrial Edge, describes the stack for clusters running on manufacturing plants, which are basically 3 scalable masters cluster that will register into ACM. As we explained in our previous video, our implementation of blueprints is structured into 3 different layers. A base layer with common configuration, a profile layer with a specific configuration for footprints or purposes, and a site layer with a specific information for a single cluster, such as name, domain, hardware configuration, etc. As you can see here, we have defined 3 different sites, one representing our testbed for industrial edge use cases running on bare metal, and 2 sites running on public clouds, AWS and GCP, for testing purposes. We are going to deploy today the staging edge dev cluster OpenShift.com site that runs on AWS. As we talked about in the previous video, each layer has the same structure, and it covers both day 1 and day 2 operations. 00 install config will compose an install config.yaml. 01 cluster mods will patch or add new manifests to the config directory that will be consumed by the OpenShift installer. 02 cluster add-ons to deploy extra operators such as the GPU operator, SRUV operator, Tekton, ACM registration manifests, etc. once the cluster is deployed. And 03 services to deploy workloads and applications. If we go to 00 install config, we will see a set of manifests. The most important one is the customization.yaml manifest. That is key to use customize. This file declares the customization that we want to apply on our manifests. In this case, we start from a base. That means our set of site manifest will inherit the manifest located in this URL, which is basically our profile for AWS. We use a couple of patching strategies to add or replace the name and the domain of the cluster. And finally, we use a transformer called siteconfig.yaml. This siteconfig is a customized plugin that we have developed to replace a number of things like the SSH key, pull secrets, etc. This strategy allows us to push a blueprint to a Git repo without revealing confidential information. As we have just seen, this site definition inherits from a profile called production AWS. Again, this customization.yaml inherits from the base layer, as we can see here, and it patches the install config.yaml. As it's a profile for AWS, it patches the platform section to include a specific region. Finally, let's take a look at the base layer in the 00 install config stage. Once again, we have a customization.yaml. Let me emphasize that this one doesn't have a base section because it doesn't inherit from a lower entity. It just uses the resource called install-config.yaml. This file describes a 3 masters, 0 workers cluster. The pull secret and the SSH key will be replaced by our customized plugin, and the missing parts like the platform section will be added when we render the manifest to get a full-fledged install-config.yaml with the right name, domain, platform, etc. We have only described the workflow for the install-config.yaml stage, where our site inherits from the AWS profile that also inherits from the base layer. This workflow is used for all the stages. Now, let's get our hands dirty and deploy our Industrial Edge blueprint on AWS. First of all, you need to have your AWS credentials on the right path and have a number of files located in the .kni folder under your home directory. You need to store your pull secret, SSH key, and more with those specific file names. If you realize there are already two directories that correspond to two different sites, one leveraging the Management Hub blueprint and the other one is the bare metal site that we pointed out earlier. The first step would be to download the required binaries. We use knictl fetch requirement command pointing to our Git repo. Under the hood, knictl creates a new folder with the site name and it will download the requirements and the blueprint definition. The next step is to render the manifest to something consumable by the OpenShift installer. The command knictl prepare manifest does this for you. Behind the scenes, this command will create a customization.yaml with a set of resources that correspond to all the manifests generated by the installer using the install-config.yaml as input. In this step, knictl can perform two different things. Either we patch some of the existing manifests like ingress replicas, for example, or add new manifests such as machine configs to disable DHCP on certain interfaces. In order to perform this manually, we should locate the siteconfig customize plugin with an environment variable and execute customize build. If we run customize on the 00 install config stage, we see the whole install-config.yaml that describes the number of nodes, footprint, etc. If we run customize on the 01 cluster mods stage, we will get all the manifests with the corresponding modifications and patches. Finally, we use the OpenShift install binary to trigger the deployment, and we will pass the final manifest directory that describes our cluster based on this blueprint. Awesome! Our deployment has finished successfully. Remember that this running cluster is completely described by the three layers of our blueprint and the two stages corresponding to day one operations. To have our edge site in a state that reflects the description made by our blueprint, we still need to deploy our add-ons and services. For that, the kni apply workloads command will basically perform an OC apply -k of the two remaining stages, 02 cluster add-ons and 03 services. Customize allows you to apply resources in a specific order. However, we cannot control how CRDs and CRs are applied, so we might encounter some issues deploying operators. A very simple way to work around this issue is to have a small loop applying the resources again. As you can see, we are performing a registration process of our edge site cluster into ACM that is running on a central management hub. This will deploy an operator to control the endpoint, CRD, and a set of other resources. As a summary, let's recap what the knictl tool does behind the scenes. First of all, we need to download the blueprint definition and the binaries that are involved in the process. For this, we have the knictl fetch requirements command. It will download the OC binary, OpenShift install, kubectl, and customize binaries in a specific directory. In order to render the manifest downloaded by the first step, we have knictl prepare manifests command. It involves two stages. The first one involves the install config stage that, using a base install config.yaml, it will patch the name, domain, pool secret, SSH key, and add more things like bare metal machines information, regions in public clouds, etc. The second stage is the cluster mods stage. This will generate manifest based on the install config.yaml generated in the first stage, and it will create a customization.yaml with this recently created manifest. It will apply customize either to patch existing manifests or adding new full manifest to, for example, create a machine config that will disable DHCP interfaces. Once that the manifests are rendered, we will use OpenShift install binary to create our cluster, and we will pass this set of manifests as our configuration directory. Once the deployment is completed, we will use knictl apply workloads command. This will basically do an OC apply -k in the two last stages, the cluster add-ons and services. With this command, we will add the extra operators that are needed in our platform and the workloads that are running on top. Thank you very much. In the next video, we will learn how to deploy a blueprint on bare metal.